will discuss the topic energy from chapter 11 work and energy. In our previous class we learned about work, its scientific concept, its formula, its SI unit and its types with examples. Now we will move to next topic, energy. What is energy? You are very familiar with this term energy because in day-to-day life you use this word very often. Now, do you understand its meaning? Do you understand its essence, its importance? I am going to tell you. What is energy? Energy is the capability to do work. Energy is the capability to do work. So it is clear from the definition that it is the energy which makes an object able or capable to do work. If object has energy, then it is able to do a particular work. If it doesn't have energy, then it is not able to do any work. So for doing work, it has to acquire or obtain energy. After that, it can do a particular work. So energy is the capability or capacity to do work. Now next question. How does energy make an object to do work? This we can understand with the help of this flowchart. Now what does this flowchart tell? This flowchart tells that if any object does work on another object, before doing work, that first object must have energy. If it doesn't have energy, then that object has to acquire or obtain or gain energy. So first of all, object acquires or obtains energy. Then it expends that energy on another object. As a result, transfer of energy takes place from first object to second object. So that second object finally gets energy, and due to that energy it displaces or moves in a direction. Hence work is done on that object by first object. For example, in a match of golf player raises the golf stick to a certain height. So when he raises the golf stick to a certain height, that golf stick obtains energy due to increase in height called potential energy. Then that golf stick moves down. So it comes into motion from height. So its potential energy is converted into kinetic energy. Then it hits the golf ball. As it hits the golf ball, it expends its kinetic energy on the golf ball. As a result, golf stick's kinetic energy is transferred into golf ball. Now, golf ball has kinetic energy, due to which it displaces, it moves in a direction. In this way, golf stick does work on golf ball. So work is done by golf stick on golf ball. Now another example. In this example, an iron nail gets pierced or is driven into the wooden table or block by hammer. So here hammer is doing work on iron nail. How is that? First of all, hammer is raised to a certain height. When it is raised to a certain height, due to increase in height, it acquires an energy called potential energy. Then that hammer is moved down. So it comes into motion from a height, so its potential energy is converted into kinetic energy. Then it strikes with the nail. As it strikes with the nail or iron nail, it expends its kinetic energy on the iron nail. In this way, its kinetic energy is transferred into the iron nail. As a result, now iron nail has kinetic energy, due to which it moves or gets pierced into the wooden table or block. In this way, a work is done by hammer on the iron nail. In both the cases, you must have observed that in first case golf stick, in second case hammer. Both are raised to a certain height. After attaining a certain height, they acquire an energy called potential energy. So first of all, objects who are doing work on another objects acquiring energy. Then they are moved down, so their potential energy is converted into kinetic energy. Then they are struck with another object. In this way, they expend their energy on another object. Like golf sticks, energy is expend on golf ball. Hammer's energy is expend on iron nail. As a result, transfer of energy takes place from first object to second object, from golf stick to golf ball, from hammer to iron nail. Now, second object like golf ball and iron nail, both get energy from the first object. As a result, they move or displace in a direction. In this way, work is done by first object on second object. So these examples prove that, show that energy makes us able to do work. Energy makes any object able to do work. Forms of energy. Actually, energy is not available in one form only. Energy is available in several different forms in nature, like sound energy, chemical energy, heat energy, light energy, potential energy, kinetic energy, nuclear energy, atomic energy, electrical energy, etc. So, energy is found or available in nature in several various forms. Next point, potential and kinetic energy. Both are collectively known as mechanical energy. Now, most of the energy forms found in nature are directly or indirectly derived from sun. So, sun is considered as the ultimate source of energy. For example, if we talk about electrical energy, then you have a question regarding electrical energy, that how is electrical energy derived from sun? Yes, it is directly or indirectly derived from sun. How is that? See, most of the electrical energy is generated by burning coal and petroleum. And you know that coal is formed from dead remains of plants and trees. And you know that before plants and trees die, they obtain energy from sun. So, sun's energy is transferred into plants and trees, and after that, their energy is transferred in the form of coal. And that coal is burned to produce electrical energy. So, indirectly, electrical energy is derived from sun's energy. Now, if you talk about petroleum, see, if electrical energy is generated by burning petroleum, then petroleum is formed from dead remains of plants, trees and animals. And if we talk about animals, before they die, they absorb energy from plant, and plant absorb energy from sun. So, sun's energy is transferred into plants, then into animals, and then ultimately it is transformed in the form of petroleum. And that petroleum is going to produce electrical energy. So, overall, electrical energy is indirectly derived from sun's energy. In another case, where electrical energy is generated from solar energy. So, here sun's energy is directly converted into electrical energy, sun's energy. Okay, so one or the other hand, most of the energy are derived directly or indirectly from the sun. So sun is the ultimate or main source of energy on earth. Now we will study one of the forms of energy, that is kinetic energy. Kinetic energy, it is the energy of an object due to its motion. Means if object is in motion, is in movement, then due to that motion or movement, it possesses an energy called kinetic energy. So it is the energy of an object due to its motion. For example, if I throw a stone in a particular direction, then that stone is moving due to motion, due to speed, it possesses kinetic energy. When a bullet is fired from the gun, then that bullet is moving with a velocity. So due to that motion or movement, bullet possesses kinetic energy. Okay, so these are some of the examples of kinetic energy. If you are also in motion, if you are moving, see I am moving. So due to movement or motion, I also possess kinetic energy. So kinetic energy is the energy of an object due to its motion. So if any object is in motion or movement, due to motion or movement, it possesses kinetic energy. Now, on what factors kinetic energy of an object depend? To explore this, we will perform an activity. In this activity, take a wooden table. On this wooden table, we place a toy trolley. In front of this toy trolley, we keep a wooden block of known mass at a particular distance from the toy trolley. Now, we tie this toy trolley with this span with the help of a thick thread. Remember one thing, this thick thread is made to move over the pulley so that it can move smoothly, properly, easily. Now, you have to start the activity. First of all, we put a wooden block of known mass in pan. As we put this wooden block of known mass in pan exerts a force on the toy trolley. As a result, it displaces. So, a force is applied on the object and displacement is covered by the object. It means work is done on the object. Due to this, trolley moves ahead, it displaces ahead in a particular direction. So it acquires motion. Its velocity increases. As a result, it obtains kinetic energy. When it strikes with this wooden block during motion, its kinetic energy is transferred into this wooden block. Due to that kinetic energy, wooden block also displaces, moves up to a particular distance. Now, increase mass in this pan. How's that? Keep one more wooden block of known mass in this pan. Now, mass of the pan is more. Due to more mass, it exerts more force on the toy trolley. As a result, it displaces more. So, overall work done on the toy trolley is more. When this toy trolley moves, displaces, now its motion or displacement will be more. Its velocity will be more as compared to that of previous case. So, it will acquire more kinetic energy, which is transferred into this wooden block when it is struck with this wooden block. So due to transfer of more kinetic energy in this wooden block, now wooden block displaces up to greater distance. So this activity shows that if we increase the mass, then force increases. displacement increases, work increases. In this way, displacement or motion or velocity of the object increases, which ultimately increase the kinetic energy of the object, and vice versa. Means if you decrease mass, then force decreases, displacement decreases, work decreases. As a result, motion, displacement, velocity of the object decreases, so kinetic energy will be less. It means kinetic energy depends on mass and velocity of the object. If mass increases, then velocity also increases, like in this case, which ultimately increase the kinetic energy of an object. So kinetic energy of an object depends on mass and velocity. You can take any other example also, like if a bullet is fired from a gun, then that bullet is having a great velocity. Due to that velocity, it has more kinetic energy as compared to that of stone which is thrown by our hand. In that case, stone is having less velocity, so it has less kinetic energy. So by these two examples, we can conclude that kinetic energy depends on mass and velocity. If mass is more, kinetic energy is more. If mass is less, kinetic energy is less. Secondly, if velocity of the object is more, it means motion is more, so kinetic energy is more. If velocity is less, then motion is less, kinetic energy is less. So overall kinetic energy depends on mass and velocity. But there is one more important point which you have to keep in your mind while dealing with kinetic energy. That is velocity. This factor affects kinetic energy more than mass. How's that? Formula of kinetic energy is Ek is equal to half mv square. Kinetic energy is denoted with Ek, K kinetic, T energy. So kinetic energy is denoted with Ek is equal to half m mass v velocity square. So you can see in formula, if kinetic energy is directly proportional to the mass of the object, then how can you neglect that this kinetic energy is directly proportional to the square of the velocity? It means if mass increases by 2 times, kinetic energy increases by 2 times. If it decreases by 2 times, then kinetic energy also decreases by 2 times. But if velocity increases by 2 times, then its square will be 4. So kinetic energy will be increased by 4 times. And if it decreases by 2 times, it means square is 4. It means kinetic energy will be decreased by 4 times. Okay? So this shows that impact of velocity is more on kinetic energy than that of mass. Just now I have told you the expression or formula for kinetic energy, that is Ek is equal to half mv square. How is this equation or formula derived? That I am going to derive mathematically. Now mathematical derivation for the expression of kinetic energy. Here we are going to derive expression or formula of kinetic energy mathematically. Let us consider that there is an object having mass small m. Its initial velocity is u. Now this object is at rest, so its initial velocity u is equal to 0 meter per second. Then a force is applied on the object, denoted with F. Due to that force, object covers a displacement s and attains a final velocity v. transfer it from left to right side, then 2a will divide v square minus u square, and then we will have s is equal to v square minus u square upon 2a. This is our fourth step. Now what next? Now we have to put the values of f and s from steps 2 and 4 in first step. Then we will have w is equal to, in place of f, put the value of f, that is and a, from second step, into s, put the value of s from fourth step in first step, that is v square minus u square upon 2a. This is fifth step. Divide a by a, we will get 1. W is equal to m into 1, m into v square minus u square. Already I told you, object was at rest, so its initial velocity is 0 meter per second. U is equal to 0 meter per second. So in place of u, we can write 0 square upon 2. This is our sixth step. W is equal to m into v square minus 0, square of 0, 0, upon 2. This is seventh step. Now W is equal to m into v square minus 0, v square upon 2. This is eighth step. W is equal to m into v square, mv square upon 2. mv square upon 2 can be written as half mv square. This is next step. Both are same. So what is the work done on the object? Equal to half mv square. So this is the work done on this object. Now when this work is done on this object, then this object acquires motion, acquires kinetic energy, because before this work, this object was at rest. This was a stationary object and had an initial velocity 0 meter per second. But when this work is done on this object, it acquires motion, it acquires kinetic energy. So due to work, it acquires kinetic energy. So whatever work is done on the object, that much kinetic energy it has. So work is equal to kinetic energy. So in place of work, we can write kinetic energy is equal to half mv square. This is 10th step. So in this way, expression or formula of kinetic energy is derived mathematically. Now, next form of energy, that is potential energy. What is potential energy? It is the energy of an object due to its position. Means if object acquires a position, a higher position, so due to that higher position, it obtains an energy called potential energy. So due to higher position or position, it possesses an energy called potential energy. Now, what do I mean by higher position? See, there is an object. If its position increases or expands horizontally or vertically, then due to increase in position, due to higher position, it acquires an energy called potential energy. For example, this is a spring or slinky having this position. Now, stretch its one end, pull its one end. was this. Now its position is increased horizontally. Okay, due to increase in position, due to this increased position, it acquires potential energy. Now this stretched spring or slinky has potential energy due to increase in position. Another example, there is an object kept on a ground. Now this object is raised to a certain height. So its position increases vertically. Due to increase in position, due to higher position or height, it acquires potential energy. Now this object at a height has potential energy. So what do these examples say about potential energy? It says that if the position of an object increases horizontally or vertically due to increase in position, due to higher position, it acquires an energy called potential energy. That is why it is the energy of an object due to its position. More position, high position, more potential energy. Now, what is the formula or expression for potential energy? It is equal to EP is equal to mgh, where EP stands for potential energy, E energy, P potential. So EP together stands for potential energy is equal to m mass, G acceleration due to gravity, which has a constant value of 9.8 meter per second square. H stands for height. So it is clear from this formula that this is applicable for these kind of cases where object is raised to a certain height, where object's position increases vertically, and due to height or higher position it acquires potential energy, which is equal to mgh. M mass, G acceleration due to gravity, having a constant value 9.8 meter per second square, and h this vertical height. Now, how is this equation derived? You can take this example. There is an object having mass m kept on the ground. Now it is raised to a certain height h. So due to increase in position, due to this higher position or height, it acquires an energy called potential energy. Now, what is its potential energy? That we have to derive mathematically. First of all, when this object having mass m is raised to a certain height, then a force is applied on this object due to which it covers a height or a displacement. So force is applied on the object due to which it covers a height or displacement. So work is done on this object. So work is done on this object. Work is equal to F into S. This is first step. Now F. F means force. You know what is the formula of force? M into A. Second step. Here acceleration is produced due to gravity because this object is raised to a certain height. So when it is raised to a certain height, it experiences an acceleration due to gravity, small g. So in place of A, we will write g. So F is equal to mg. Now F, in place of F, we can write mg from step 2. So put the value of F from step 2 in step 1. So W is equal to F, in place of F we have written mg into S. What is the displacement here? Displacement is h. So W is equal to mgh. So what is the work done on this object? That is mgh. This object of mass m was kept on the ground. So when it was kept on the ground, at that time it had no height, it had no potential energy. But when a force is applied and due to that force it covers a displacement or height h, then it acquires a height, it acquires a potential energy. So when work is done on the object, then it acquires a height, it acquires a potential energy. So whatever work is done on this object, that much potential energy it acquires. So work is equal to potential energy. So in place of work we can write EP, potential energy, is equal to mgh. So what is the potential energy of the object? mgh. The fourth step. So in this way expression or formula of potential energy is derived mathematically. Now potential energy is directly proportional to the height of the object. If height increases, potential energy increases. If it decreases, potential energy also decreases. It is clear, because as you increase the height, potential energy will be increased. As you decrease the height, potential energy will be decreased. So potential energy depends on the vertical height from the ground. Now one more important thing. There is an object having same mass m. It is kept on the ground, then it is raised to a certain height in this direction. Then it is turned towards right. Then it is again moved up. Then it turns towards left. Then again moves up and ultimately reach to the same height from the ground h. Difference in both the cases is that this object is raised to a certain height h by this route, by this path, which is straight vertically upward. But in second case, object having same mass is raised to the same vertical height h from the ground, but the path or route by which it is raised to this height is quite different. It is raised to this height by following a straight path, but here this object is raised to same vertical height but by following different path. First it is moved up, then right, then up, then left, and then up. So its path by which it is raised to a certain height is different from previous one. Which of the objects has more potential energy? Answer is both objects have same potential energy, because I already told you potential energy is equal to mgh. So it is clear from the formula potential energy is directly proportional to the height, vertical height from the ground. Both objects achieve or attain same vertical height h from the ground. So their heights are same. Acceleration due to gravity small g is always same, constant 9.8 meter per second square. Masses are same, so potential energies of both the objects are same. So this shows that potential energy depends on height, vertical height from the ground, not on the path by which it is raised to that height. This is all for today. Thank you. Have a nice day.